English podcast and tech. I am Charles. Welcome back. Look around you right now. If there is a computer, a phone, or a tablet nearby, I want you to think about something. Inside that device, there is a processor. There is memory. There is a way to receive input and produce output. Every computer ever built follows the same basic structure, the same fundamental design. One man defined that design. His name is John von Neumann. This is episode 7 of The People Who Built the Digital World. Today we meet one of the most brilliant and most controversial minds in the history of science. Let's begin. Let's learn today's key words. The first word is architecture. In computing, architecture means the fundamental design of a computer, how its parts are organized, and how they work together. Every laptop, smartphone, and server today uses a design called the von Neumann architecture, named after today's person. Repeat after me, architecture. The second word is memory. In computing, memory is the space where a computer stores information while it is working. Von Neumann's key idea was that both the program and the data it processes should be stored together in the same memory. Before his idea, this was not how computers worked. Repeat after me, memory. The third word is stored program. A stored program computer is a computer that keeps its instructions in memory, so it can be reprogrammed without changing its physical hardware. Before stored program computers, changing what a computer did meant physically rewiring the machine. Von Neumann's idea changed that forever. Repeat after me, stored program. The fourth word is nuclear. Nuclear means related to the energy stored in the nucleus of an atom. John von Neumann worked on the Manhattan Project, the secret American program to develop the first nuclear weapons during World War II. Repeat after me, nuclear. The fifth word is processor. A processor is the component of a computer that executes instructions. It is the brain of the machine. In von Neumann's architecture, the processor reads instructions from memory, executes them one by one, and stores the results back in memory. Repeat after me, processor. The sixth word is genius. A genius is a person with extraordinary natural intelligence or creative ability. Von Neumann is widely considered one of the greatest geniuses of the 20th century. He could memorize entire books and recall them word for word years later. Repeat after me, genius. The seventh word is collaborate. To collaborate means to work together with other people toward a common goal. Von Neumann collaborated with the greatest scientists of his time, including Alan Turing, who we met in episode 4. Repeat after me, collaborate. The eighth word is bottleneck. A bottleneck is a point in a system where the flow of information or work becomes slow, limiting the overall performance. Von Neumann's architecture has a famous limitation called the von Neumann bottleneck. The processor has to wait for data to travel from memory, which slows things down. Repeat after me, bottleneck. 8 words: architecture, memory, stored program, nuclear, processor, genius, collaborate, bottleneck. Now let's hear his story. The year is 1903. In Budapest, Hungary, a boy is born. His name is János Lajos Neumann. Later, when he moves to the United States, he will be known as John von Neumann. Budapest in 1903 is a vibrant, intellectual city. Hungary is producing some of the greatest scientific minds of the century. János is, from the very beginning, extraordinary. At the age of 6, he memorizes a phone book. Not a page, the entire phone book. At 8, he is studying calculus. At 12, he is reading university-level mathematics textbooks. His father hires university professors to give him private lessons because the school system has nothing more to teach him. One of his tutors later says, "János does not study mathematics. Mathematics is simply the natural language in which his mind thinks." By the age of 17, János has already published his first mathematical paper. He earns 2 degrees simultaneously, a degree in chemical engineering and a PhD in mathematics, at the age of 22. He becomes a professor at Berlin University at 23, the youngest in the university's history. In 1930, von Neumann is invited to Princeton University in the United States. He accepts immediately. When the Nazi Party rises to power in Germany in 1933, von Neumann, who is Jewish, decides not to return to Europe. He joins the newly created Institute for Advanced Study at Princeton, alongside Albert Einstein and other great scientists of the time. At Princeton, von Neumann works on an enormous range of subjects: quantum mechanics, game theory, economics, and mathematics. His colleagues are amazed by his speed. He can solve in minutes problems that take others days. Then, World War II begins, and von Neumann's life changes direction completely. The United States Army needs scientists to solve complex military problems. Von Neumann becomes a consultant for the Army, the Navy, and eventually the Manhattan Project. On the Manhattan Project, von Neumann works on the mathematics of nuclear explosions. His calculations help determine the precise design of the bomb. But to do those calculations, he needs something that does not yet fully exist: a fast, programmable electronic computer. In 1944, von Neumann learns about a project at the University of Pennsylvania, a machine called ENIAC. ENIAC is one of the first fully electronic computers ever built. It fills an entire room, 160 square meters. It contains 18,000 vacuum tubes, electronic components that generate enormous amounts of heat and fail constantly. Von Neumann joins the ENIAC project and immediately identifies its biggest limitation. To change what ENIAC does, operators have to physically rewire the machine, plug cables into different sockets, change switch settings. It can take days. Von Neumann has a fundamental insight. What if the program, the instructions, were stored in memory, just like the data? If the computer could read its own instructions from memory, you could change what it does simply by loading a different program, without touching the hardware. This idea seems simple, but it is one of the most important ideas in the history of computing. In 1945, von Neumann writes a document called First Draft of a Report on the EDVAC. In this document, he describes the architecture of a stored program computer, a machine with a processor, memory, input, and output, where the program lives in memory alongside the data. This document circulates widely among computer scientists and engineers. It becomes the blueprint for almost every computer built after it. Today, this design is called the von Neumann architecture. Every computer you have ever used, every laptop, every smartphone, every gaming console, is based on this architecture. However, the story of this document is also controversial. The original ideas for the stored program concept were developed by a team, including engineers John Eckert and John Mauchly, who built ENIAC. Because von Neumann's name was on the document, and because he was already famous, the architecture was named after him alone. Eckert and Mauchly felt this was unfair. The debate about who deserves the credit continues among historians today. After the war, von Neumann continues working on computers and mathematics. He also thinks deeply about biological systems, and artificial life. He develops the concept of self-replicating machines, machines that can build copies of themselves. This idea is the theoretical foundation of computer viruses and cellular automata. In 1957, John von Neumann dies of cancer at the age of 53. His death is a profound loss for science. He is considered by many to be the last person who understood all of mathematics, every branch, every field. After von Neumann, mathematics became too large for any single mind to contain. Today, his name is everywhere in computing, but most people who use computers every day have never heard of him. Every time your phone runs an app, every time your laptop opens a program, every time any computer anywhere executes any instruction, it follows the design that John von Neumann described in 1945. Let's review the 8 key words from today's episode. Architecture, the fundamental design of a computer. The von Neumann architecture is the design used by almost every computer ever built. Memory, the space where a computer stores information while working. Von Neumann's key idea was to store both the program and the data in the same memory. Stored program, a computer that keeps its instructions in memory. Before this idea, changing what a computer did required physically rewiring the machine. Nuclear, related to the energy in an atom's nucleus. Von Neumann worked on the Manhattan Project, helping design the first nuclear weapons. Processor, the component that executes instructions. In von Neumann's architecture, the processor reads instructions from memory and executes them one by one. Genius, a person with extraordinary intelligence. Von Neumann memorized entire phone books as a child and solved in minutes what took others days. Collaborate, to work together toward a common goal. Von Neumann collaborated with Turing, Einstein, and the greatest scientists of the 20th century. Bottleneck, a point where a system becomes slow. The von Neumann bottleneck is a real limitation. The processor must wait for data to arrive from memory. That is the story of John von Neumann, the man whose design lives inside every computer on the planet. A child who memorized phone books. A mathematician who worked on nuclear weapons. An architect whose blueprint the entire world still follows today. Today's phrase to remember is, the design of every computer starts with his idea. Repeat after me. The design of every computer starts with his idea. One more time. The design of every computer starts with his idea. In the next episode, we meet William Shockley, the man who co-invented the transistor, the tiny device that makes modern electronics possible. Your question for today, write your answer in English in the comments. Is it fair that the architecture was named only after von Neumann? What do you think? See you in episode 8. This is Charles, and this is English Podcast and Tech.